If you're working at a growing company, you'll realize that a positive correlation exists between company growth and the scale of ingress data. This could be from increased usage for existing applications or newly added applications and features. It's up to the data engineer to organize, optimize, process, govern, and serve this growing data to the consumers while maintaining service-level agreements, SLAs. Most likely, these SLAs were guaranteed to the consumers without the data engineer's input. The first thing you learn when working with such a large amount of data is that when the data processing starts to encroach toward the guarantees made by these SLAs, more focus is put on staying within the SLAs, and things like data governance are marginalized. This, in turn, generates a lot of distrust in the data being served and ultimately distrust in the analytics, the same analytics that can be used to improve operational applications to generate more revenue or prevent revenue loss. If you replicate this problem across all lines of business in the enterprise, you start to get very unhappy data engineers, trying to speed up data pipelines within the capacity of the data lake and data processing clusters. This is the position where I found myself more often than not. So what is a data mesh? The term mesh in data mesh was taken from the term service mesh, which is a means of adding observability, security, discovery, and reliability at the platform level rather than the application layer. A service mesh is typically implemented as a scalable set of network proxies deployed alongside application code, a pattern sometimes called a sidecar. These proxies handle communication between microservices and also act as a point where service mesh features are introduced. Microservice architecture is at the core of a streaming data mesh architecture and introduces a fundamental change that decomposes monolithic applications by creating loosely coupled, smaller, highly maintainable, agile, and independently scalable services beyond the capacity of any monolithic architecture. In Figure 1-1, which can be found in the bonus material for this book, see this decomposition of the monolithic application to create a more scalable microservice architecture without losing the business purpose of the application. A data mesh seeks to accomplish the same goals that microservices achieved for monolithic applications. In Figure 1-2, a data mesh tries to create the same loosely coupled, smaller, highly maintainable, agile, and independently scalable data products beyond the capacity of any monolithic data lake architecture. Zhamak Dehghani, whom I refer to as ZD in this book, is the pioneer of the data mesh pattern. If you are not familiar with ZD and her data mesh blog, I highly recommend reading it, as well as her very popular book, Data Mesh, O'Reilly. I will introduce a simple overview to help you get a basic understanding of the pillars that make up the data mesh architectural pattern, so that I can refer to them throughout the book.